Hello, I welcome you all. The problem reads determine the moment of force F about point O. Express the result as a Cartesian vector. Right, so what do we do? So we need to convert this force into a vector force and also find the position vector to the line of the action of the force. So we have two alternatives. We have this one here, which we can call RC. We do have this one here, which we can call RB. So any of these can give us the same results. So moment about point O here is just equal to RC cross F, which I'm going to call FBC, is also equal to RB cross FBC. So any of these will give us the same results. Okay, so let's do so. So yeah, I'll pick this one myself. Okay, if you want, you can pick this. It's really up to you. I'm just including them, not that I'm going to use both of them. It's really up to you. We have that one. We have that one. Okay. Okay, yeah, like so. And then this one here, we'll call it FBC. Okay. All right. So what do we do? So we know that FBC, converting it into a vector, this is equal to F, okay, BC, unit vector BC, okay, and which is just equal to, of course, F, UBC just RBC divided by magnitude of RBC. Okay, so the coordinates for this here, this is in the X is 1, in the Y it is 4, and in the Z it is 2. And this one it is 5, 0, 0. Okay, great. That's 5. 1 plus 4, 5. So this just becomes equal to, we have 120. All right, and then I open bracket FBC. So we are just subtracting RC minus RB. This, okay. RBC is just RC minus RBC. This is what we're doing basically. Remember vectors? So C, that's 5 minus 1, that is 4I. And then 0 minus the other one, that's minus 4J. 0 minus the other one, that is 2K. Then divided by magnitude of this, that's 4 squared plus 4 squared plus 2 squared, that is 32 plus 4, 36. Square root of 36 is 6. So there we go, like that. And therefore our FBC, if we worked out this, 6 into 120, that is 20. 6 into 120, that is 20. 20 by 4, that is 80I. Then 20 by 4 also is minus 80J. 20 by 2, that is 40K. So found BC, FBC. So like I said, we are going to use RC. RC is just 5I. So it's really up to you to choose which one to use. For me, I'll use this one. So you can cross this directly if you want to, which I can do. So I'll do it this twice. I mean in two ways. So moment about point O is just going to be equal to RC okay, cross FBC, which is just equal to 5I cross 80I minus this minus 40K. Okay, so you know that the way we cross, we are moving like this. So I cross J is K, J cross K is I, in that manner, and in the opposite direction we have a negative sign, and then this I cross I is 0. Okay, so let's do that. So for this one, this just becomes, this part gives us a 0. Okay, that's a 0, so I'll just put a 0 there. Then I cross J, we said as of course there's a minus there. This is 80, sorry, this is 80 here and not 8J. So 5 by 8, that is there 400, 5 by 80, 400K. So I by J, and then I by K, that's in the opposite direction, I, J, K. We are moving in that manner. So IK becomes J, so it's a minus, there's already a minus there, so it just becomes a plus 200J. So this is one way of solving this. Therefore, our moment about point O is just equal to 200J minus 400K. Okay, and the units here, it is pounds feet. If you don't want this, then you can use the table. Remember the table? Okay, RC cross FBC, and this is equal to, you draw the table. Remember the table, that determinant kind of table. So you draw this table. On top here we put I, J, K. If you don't want to use this direct approach, then here the follow-up is the lever arm or the position vector. This is 0, 0. Then the follow-up is the force 80 minus 80 and minus 40. Then we can start working out this. We start with I. So I here, both of them are just zeros, right? This and this minus. Then this one, we always introduce a minus. So this by this, okay, and then this by this, it is minus 400, is it? No, minus 20. 4 by this is 20, I mean 200, and then minus that, that's a 0. Then we do have plus K, which is this, so just this by this, that's a minus 400. Okay, and therefore from this we can also get the same solution, which is just a 200J minus 400K. Okay, pounds feet. Right, I guess this is really about it. The solution is the same regardless of which technique you use. It doesn't matter. You can use this matrix table, or you can cross directly. If you need to know how each unit vector is operated on when you are using the cross product rule. So I hope this particular video was helpful. We've expressed the moment of a force about point O in Cartesian vector formatting. So bye bye, and see you in my next screencast.